everybody. Kent Martz here on our Facebook and social media broadcast. I have a special guest with me today, Dr. Daniel Barth. Dr. D, nice to have you here.
Good to see you, Kent.
He is a professor in the College of Education at the University of Arkansas.
That's right.
He teaches the teachers to be teachers of science.
That's right. We run the Astronomy for Educators program, training our next generation of educators to teach our children in astronomy and space science.
So he's got a couple of cool books that you can see over in the carousel. Tell us about those. We're not in the carousel real quick. A couple of cool books that you can buy that he has. Talk about those real quick.
I started writing science fiction a long time ago, but my books are basically real science. I wanted to teach kids science with exciting books of fiction, but I found that there were none that were either family friendly, they weren't family friendly, or they had magic wands and unicorns, and so they said, well, you can't do it. And I said, just watch me, I'll write those books.
And what are the names of those?
Maurice on the Moon, Maurice in the Doomed Colony of Mars, and Crisis on the Far Side is the third one in the series.
Okay. And you just came out with that one, didn't you? I remember you coming out with that book.
The Crisis on the Far Side?
I think, didn't I?
That was a few years back,
okay.
Yeah. And there's a fourth one in the series called Revolt in Volkov Crater. That's not out yet. But Revolt in Volkov Crater.
And Volkov Crater is on Mars again.
It's back on the moon.
It's back on the moon. It's on the moon.
You bet.
Okay. All right. So anyway, we're going to go through our lineup real quick today. The 52 degree eyepieces are on sale today, along with a lot of other eyepieces. I've got the 52 degrees series here. We've got the 40, the 20, the 10, and the 4.5. Yep, I got them right. I put them in the correct order that I remember.
Indeed.
So these are 52 degree apparent field of view, which means if you take the eyepiece and hold it up to your eyeball like this, let me see if I can get
your eye.
Is it getting it, Daniel?
You're pretty close.
So it's hard to get. Anyway, it's hard. I can't see the camera and know where to line. Anyway, what that means is that you can see a 52 degree angle. So this is a 52 degree eyepiece.
That's right.
There's some math that we're not going to talk about today that talks about how you get a true field of view when you put it on a telescope.
The thing that people need to know, though, is that when you get a nice wide field of view on your eyepiece, you get a wider field of view through your telescope. Right. It's easier to aim. It's easier to find and track your target.
It's easier on your eye.
It is.
It's easier on your brain. It's just the more.
And if you're wearing specs, it works a lot better. You betcha.
So those wide fields, and they go up to, we have a 120 degree 3-inch eyepiece, a very specialized eyepiece.
Yeah.
But you just got to have a really correct scope for it. But the 110 degree eyepieces, 92, 82, those are really super wide fields.
They're superb.
The more your eyes relax, the better your eye is when you look through it. And that makes your brain relax. And when you're relaxed, you see more.
I use the Explore 82 degree field series eyepieces in my work teaching astronomy at the University of Arkansas. And I train young teachers to teach astronomy. Right. And that's the equipment of choice that we use for them.
So one of the cool things is, I like the 40 degree eyepiece. Most of the viewing I do through a telescope is at low power. I find it more pleasant, just more comfortable all the way around. Even planets, Jupiter, Saturn, I use a wide field eyepiece. Now look at the size of the hole right there that the light comes out of. Yes, there's some theory that says you want all the light down to a 3 or 4 millimeter diameter eyepiece, and you do, so all the light gathered by the telescope goes into your eye, and that's all well and good. The problem is keeping that centered on your pupil, because your head's always is difficult at best.
Especially for a beginner.
It's super hard for a beginner,
yes,
and nigh on impossible sometimes.
And that's exactly why, because I train young people who are not astronomers,
right,
who are learning to teach astronomy and space science to children. We want them to have an eyepiece that's very comfortable and very easy to use, and that's why I selected those for my program,
right,
the 82 degree field.
So all those eyepieces are on sale. You can go to where you buy your equipment and take a look at them. We won't get into the theory of magnification. Okay, we will real quick. The bigger the number, this is a 40, the bigger the number, the less magnification, which is exactly opposite what most people think. Because it's division, right, not multiplication.
You're taking the focal length of the telescope, which is printed on the telescope near the focuser usually. It's the focal length of the telescope divided by the focal length of the eyepiece. So if you have a 1,000 millimeter telescope and you're dividing by 40, then you go ahead and you work out what your Magnification
So
is.
to make it easier, let's say is a 100. We could do it easy enough. This is how I do it. If it's 100 millimeter focal length and a 40 millimeter eyepiece, that will go in 80. So it'd be 2.5 times, right?
Right.
Which means it'd be 25 times on a 1,000
that's
1,000 millimeter telescope.
Right.
And here's the cool thing: because it's division, every time you cut this number in half from the 40 to the 20. So if this is 2.5
25 power
or 25 power, this is
50 power.
50, and this is it's a 10, 100 power.
100 power.
And the 4.5, we're going to round it to a 5.
To a 5. That's 200 power.
That's 200 power. So
bet.
it makes the math real easy.
It does.
And this is my theory on buying eyepieces. You can buy the whole set if you want to, but for a beginner, buying like a 40, a 20, a 10, and a 5 makes sense because every time you double, you make the area that you see smaller. And if you go from a 10 to a 4.5, if you go from a 10 to a 4.5, you're going from 25 power to 250 power.
Right.
And you won't find what you're looking for.
And
So you take steps.
if folks have to economize, pick the big eyepiece because you'll find the higher the magnification, the more pristine conditions of sky you need to use it.
And the less you're going to use the eyepiece.
Correct.
The less
You're going to use your low power eyepiece a lot more often. So if you have to remove one from the series, stick with your wider field or your lower power eyepieces. You're going to get more use and more enjoyment out of it.
Which is crazy because people think they crave magnification.
They do.
And they don't think they crave it. They crave it.
When I show telescopes, when I take them out for a star party or something like that at the school, almost the first question I get all the time: how many power is that telescope?
Right.
Because for years and years and years and years, department stores sold magnification as quality, and it's not true.
And they sold it far in excess of what that telescope is capable
that's
of.
there's a whole nother story there.
And we don't. Explore Scientific does not do that, as
No,
you
you
well
don't.
know. We're very honest about the magnification
don't. Yeah.
our telescopes can achieve.
Says cool.
Say, hey, Harold, nice to see you. And so, anybody else, give us a shout out. We've got a couple more minutes, and we're going to take off because we got to.
That's right.
Hop over to our live broadcast on Amazon.
That's right. Generally, I recommend when
but-
people start using an eyepiece
On
that-
Amazon, you
telescope.
can see the entirety of
Oh, sure.
Oh
this
yeah, you can see all
live
right. Come on to Amazon
for
Live, and you're going to see
an
all the other
hour
products.
at least.
We're going to talk about the IXOS 100 paired with the First Light AR 80 millimeter diameter, 600 millimeter focal length telescope.
There you go.
Run with an iPad, an Android tablet, or a Windows tablet, desktop, or laptop computer.
There you go.
Using Explore Stars app. We also are going to talk about a 102 millimeter, 1,000 millimeter focal length telescope on an equatorial, equatorial German equatorial mount.
Yeah.
And a MacCas 127 on a German equatorial mount. So let me
And
go
the
ahead
good
and wrap
news
it up.
is,
Say again.
the good news is that since we have a guest, you'll hear very little from me unless I have to impart information.
And the problem is,
That's good news.
Paul jumps in and doesn't let me go to where I'm going down my trail of joy. And so I know where I'm going, and he jumps ahead a couple of chapters, and it's like, Paul, quit jumping ahead. I'm going to get there at some point.
At some point.
So,
At some point, yes.
yeah, exactly.
At some point.
At the point that it needs to be presented in the proper order,
And can't
as
speak.
educators
And
understand.
can't
Don't you
speak.
love impatient people?
That's
Let's go.
exactly. They can't. Now I did it too. I mean, when I was in science class, we read ahead, and but that was learning. But but Professor Dr. Merriweather at Springville High School in physics had a very precise order. He was teaching things because one thing goes to another.
Yes.
So we're gonna go ahead and get out of here. He's got to get ready to set up for the live. We're out of here. I'm Kent. He's Dr. D. I work for Explore Scientific. Thanks for joining us. We'll see you next time.
Bye,
Bye-bye.
everybody.